Hello everyone and welcome to Homework Help for Lesson 6.2. Today we'll be graphing exponential equations and working on problems 2, 3, and 4. So as always, we'll start with some notes first and then dive into some examples. Okay, so this here, I'm about to highlight it. This is the basic format of every exponential equation. Notice a couple things. We have a base. That base is called, I labeled it B. It's underneath the exponent. That base is critically important to identify because if that base is greater than 1, then we have a growth curve that looks like this. It starts slow and then it grows as it moves to the right. But if that base is less than 1, so if that base is like 0.5 or if it's 1 out of 3, if anything less than 1, then we have a decay graph, which starts high, which actually starts high and gets lower and lower and then flattens out as it moves to the right. So we have growth versus decay. Next, we have a coefficient. The coefficient, I've labeled it A. Now that coefficient is important because, well, here's what it tells us. If it is greater than 0, that means it's positive. Then our graph is regular. If that coefficient is less than 0, so the number in front is negative, well, then we have a flipped graph. So let me give you an example. So let's say we have a growth curve, but then it's flipped. That means it's not going to look like this. This is what it would look like if it was regular growth, but this would be flipped growth curve. Similarly, let's say I had a decay graph. So decay graph normally looks like this, but then it was flipped, then my graph would look like that. So it's important to first try plotting the regular version, the growth or the decay, and then flip it down by treating this horizontal line as a mirror. Okay, let's keep going. So, last but not least, we have this number being added on at the end, that plus k. And that's going to be our horizontal asymptote. That tells us how high or how low this graph is going to go. So, just make sure you have these notes down, because they're going to be really helpful as we move into our examples. Okay, let's do some quick ones just to get the point across. So I'm looking at these examples here. I have f of x equals 1/3 to the x plus 2. So let's apply our knowledge. So first of all, notice that there's that our base is a fraction and that fraction is less than 1. So automatically, I know I have a decay graph because my base is less than 1. Next, I'm checking out in front. I notice that there is no number out in front. There's no coefficient. So that means that that number is actually positive. So I know that this is going to be a regular graph. It will not be flipped because there's no negative in the front. And then finally, I'm looking at the number over here at the end, and it's a positive 2. It's being added on. That means I have a horizontal asymptote at y equals positive 2. So I'll quickly sketch this. It's the decay graph, and it's regular. Oh, but it has a horizontal asymptote at y equals 2. That means that I need to go up 2, draw my invisible horizontal asymptote, and that's my decay curve. It's been shifted up 2 units because of that plus 2. Let's do another one. Okay, we're looking at our base. Our base is 2. You might say, oh, but the base is negative 2. That's not, that negative is never part of our base. So keep in mind, your base is always positive. And since 2 is greater than 1, I know I have a growth curve. Next, I'm looking out in front. Since I see a negative out in front, that means I am flipped. And then lastly, I see this plus 1 at the end, so my horizontal asymptote's at y equals 1. So let's start with a horizontal asymptote. It's been shifted up 1 unit. I'm going to draw a growth curve, but I'm going to just draw it in very lightly because I know it's flipped. So this is my curve. Another. So looking at the inside first, is this growth or decay? If you said decay, you're correct because that's less than 1. Next, look at the sign out in front. Is that regular or flipped? If you said regular, then you'd be correct because there is no negative out in the front. It's a positive. And then look at the end. What's the number being added on at the end? So since there is no number at the end, our horizontal asymptote is just y equals 0. Let's graph this. My horizontal asymptote is at y equals 0, right there. It's a decay graph, and it's regular. So if it was a decay graph that was flipped, then I would have drawn it like this. Oh gosh. Okay. Last but not least, I hope you're getting the hang of this. Let's look at we always start by looking at the base. So identify it, is it growth or decay? If you're paying close attention, you notice that that was actually a growth curve. Why? Because 4/3 is actually greater than 1. It's a fraction, but it's greater than 1. 4/3 is like 1.3 something. Next, this is decay. I know because the sign in front is negative, and it has a horizontal asymptote at y equals -5 because of that number at the end. So I'm going to shift my graph down 5 units, 3, 4, 5, draw my horizontal asymptote. And you're always drawing above the horizontal asymptote. So this is, I wrote growth and then I wrote decay. It's growth, but a flipped growth. So let's draw our growth first. And in the last step, we will flip it. And that's my actual curve. So I should erase the first one. That's my curve. Okay, I hope that was a little helpful. Now let's do some problems. So problem 2C. We need to identify regular or flipped, growth or decay, and then our horizontal asymptote. Let's do it. So our base here is E. If you didn't know, E is just a number representing 2.7 something, something, something. Just like how pi represents a number of 3.14 something, something, something. So if E is a number that represents 2.7, then is this graph growth or decay? It's going to be growth since 2.7 is greater than 1. Next, I'm looking at the sign out front. This is going to be regular since there's no negative. And my horizontal asymptote will be at y equals, can you guess? Since there's no number being added on at the end, technically it's y equals 0. So let's graph this bad boy. Go to y equals 0, draw your horizontal asymptote, and now we'll draw our regular growth. So you might be saying, Ms. Name, that's all fine and cool, but I have an actual grid in front of me, and I need to know my exact points. So let's go ahead and find at least one point on our graph to make it very specific. So we're going to find a critical point. The best way to find a critical point is to set your exponent equal to 0. So I know I'm going to set x equal to 0. Now I just need to plug it in and see what y is. So when I take f of 0, I'll have e to the 0. And anything to the 0 power gives us 1. So when x is 0, my y value is 1. There I have my critical point, 0, 1, and I have my curve. So you can be very, very precise with this by finding just one point. Let's go to 0, 1, draw a point, and we'll do our growth regular right through it. Okay, next. Beyond that, you don't need to be any more specific. You just need one point. Let's do 2f. Okay, let's identify growth or decay, regular or flipped, horizontal asymptote, and then we'll do a critical point. So, is it growth or decay? Is it regular or flipped? What's the horizontal asymptote? and then we'll do a critical point. So looking at the base, I know that this is greater than 1, so I'm growth. Looking at the sign in front, I see no negative, so that means it's a regular graph. My horizontal asymptote is y equals the number being added at the end, not the one in here with our x, but the big number being added at the end. So my horizontal asymptote is y equals 2. And to find my critical point, like we said before, set your exponent equal to 0. So when I say set it equal to 0, I really mean take the exponent and set it equal to 0, and here's why. Adding 1 to both sides, I get x equals 1. So I want to choose a point where x equals 1. When x equals 1, I want to know what the y value is. The reason that it's so easy, and the reason why I recommend to set the exponent equal to 0 is because look what happens. If I set my x to 1, then I'm doing 1 minus 1 in my exponent. 1 take away 1 is just 0. And don't we all know what anything to the 0 is? It's just 1. So make a note to yourself, anything to the power of 0 is 1. That's a very important rule. And then 1 plus 2 at the end here is 3. So I have a point when x equals 1, y equals 3. That's our critical point. We will now go and graph it. Go to your horizontal asymptote, y equals 2. Go to the point 1, 3, draw a dot. And we're drawing a growth curve that is regular. Just like that. All right, let's do problem 3. Problem 3 asks us to match these. So I'm not going to do all of them. I just want to address one, which is G, since we haven't seen it yet. The rest I'm confident you can do on your own. So let's look at letter G. We see something interesting here, which is a negative in our exponent. We haven't seen that before, at least not with graphing. But we all remember our exponent rules, hopefully, and if you don't, here's a reminder. Anytime you have something to the negative exponent power, we can rewrite that as 1 over a to the power of m, like this. So notice what I did. I took the reciprocal of the base in order to convert my exponent from a negative to a positive. But in order to do that, I had to take this guy and flip it, take the reciprocal. So instead of a over 1, it become 1 over a. Well, we'll do the same thing here. Instead of keeping it as 3 to the negative x, we'll recognize that this really means I have 1 over 3 to the power of x. And now that we have our x positive, we can identify growth or decay. And clearly now, this is actually a decay graph. So it's tricky because at first, if you look at the 3, it looks like it's growth. But it's not because of this negative exponent. So you have to take care of that exponent and then flip the base. We find out it's decay. By the way, we also know that this is regular and that the horizontal asymptote's at y equals, look at the number at the end, there's nothing being added, so it's y equals 0. So you're going to choose the graph that looks like this. All right, last problem. Number 4, it says, if the equation y equals 5 to the x is graphed, which x value would produce a point closest to the x-axis? So we can do this in 2 ways. We can first of all use our graphing knowledge to just go ahead and graph it. Y equals 5 to the x, that would be a growth curve. It would be regular, and it has a horizontal asymptote at y equals 0. See if you can figure out how I got those. Pause the video if you need time. So if it's growth and regular with a horizontal asymptote at 0, then it's going to look like this. So what do we notice? Where is this graph closest to the x-axis? clearly the further left that we go, right? The further that we approach negative infinity, then the closer to the x-axis. Whereas the further right that we go, the further away we are. It's a very large distance between our graph and the x-axis. So we want to choose the smallest point. Well, what's the smallest? Definitely not positive 4, because that would be an x value over here. 0 looks tempting, but 0 is right here. Right here. And that's not what I'm interested in. I want further to the left. 1/2 isn't going to work because that's actually getting us further away from the x-axis. It's slightly to the right of 0. -3 is what I'm looking for because -3 is the furthest point to the left, and so it's the closest to the x-axis. So that's one way you can look at the problem, is graph it and see literally at which x value is your graph closest. Here's another way we could have done the problem. We could just have tried plugging in these values and seeing which one gives us the smallest number, the closest to the x-axis. So for example, if we did 5 to the 4, that would give us some very big number, 5 times 5 times 5 times 5, which is 25 times 25, which honestly I don't even know what that is, but it's a big number. Let's see. It's 625. So imagine what we're saying. We're saying when x is 4, that our y value is all the way up at 625. Let's do the next one. If I have y equals 5 to the 0, that's y equals anything to the 0 turns into 1. So if you notice that x equals 0, the distance from the x-axis is about 1. If I did y equals 5 to the 1/2, that's really, remember your exponent rules, that's really the square root of 5. And the square root of 5 is 2.236. So you can see that's actually further up. And the last one, y equals 5 to the -3, that's y equals 1 over 5 to the 3rd power, which is 1 over 125. And 1 divided by 125 is 0.008. So which one's closest to the x-axis? Remember, the x-axis represents a y value of 0. Well, this is the guy that gets me closest. This is bigger. This is further from 0, and this is super far. So our answer, both methods, is D. All right, I hope you've found this lesson useful. We did a whole bunch of examples, and I'll see you next time.